In our next video, ladies and gentlemen, we are going to be continuing our focus on areas of regular polygons. If you remember correctly, in our previous video, we identified our area formulas for kites and rhombi. And in this video, we are going to think about how to find the area of a regular polygon, no matter what it is. So, first and foremost, the goals of this video, the success criteria we're going to be focusing on specifically, we have quite a few definitions that we're going to go on over in terms of identifying the center, the radius, the apothem, and the central angle of a regular polygon. We're going to have to be able to find the measure of said central angle and use the apothem to find the area of a regular polygon. So, just want to preface this video as we continue on. It's a lot. It sounds like a lot of information, and it can be utilized in a variety of different ways. So this is a great opportunity to kind of think about, after this video is done, possibly rewatching it a second time, if not maybe a third time, just so it all kind of sinks in, because it always does feel like a lot for students. So let's talk about, first and foremost, the first part of our success criteria, which is to make some definitions come to life. So if we think about the area of a regular polygon, what we want to take into account here is that what I have here is just a pentagon that is inscribed in a circle. The center, all right, the center of a regular polygon and the radius of a regular polygon are also the center of the circumscribed circle. Okay, if I have myself a regular polygon, or regular means all angles, all sides are congruent to each other respectively. If I circumscribe, if I make a circle around the polygon at each of its vertices, that's circumscribing a circle. The radius of that particular circle ends up being, all right, it connects to the center of the circle, and it becomes a radius, in a sense, of the polygon as well too. Okay, so it's kind of a radius of the circle, but also kind of a radius of the polygon, because it goes from its center to one of the vertices. Okay, so let's talk about that other blue line that you see on in there with its funny kind of name, the apothem. Now, the radius of the polygon is from center to vertice. Okay, the apothem is the segment from the center to the side length. Okay, so it is the segment from center to the side length, and it's the distance from a point to a side length. And I say distance from a point to a side length because, remember, the distance from a point to a line is the perpendicular segment to said line. Okay, so that's going to help us in a variety of different ways, because think about what ends up happening here. You see these two radii, you see this apothem. What we end up creating is some triangles involved within a regular polygon. And the key thing to take into account here is that for the apothem, its length is the height of the isosceles triangle created by the two radii. Because, of course, all radius are congruent. So I can say that this is the same thing as this. So we end up creating isosceles triangles, as I mentioned before, and the apothem really is just the height of that isosceles triangle. And the last little bit of definition that we're going to take a look into for today is the central angle. Okay, our central angle. So here would be a central angle APB. This would be a central angle of our regular polygon. It's got the vertex, of course, at the center of the circle, and the sides will pass through consecutive vertices. A is a vertex, the next vertex is B. Those are the consecutive vertices. So here would be our central angle created by these two radii. The measure of the central angle, now this is not new material for us, the measure of the central angle would just be the number of sides, right? N-gon would be the number of sides being divided into 360. So 360 divided by n, because this is one full circle that we have. So this would all be a bunch of little sectors of the circle. So the whole thing is 360 divided by the total number of central angles that would be created by the polygon. So let's take a look at an example of how we can think about this in a real basic context. To identify how many degrees are in each central angle of these regular polygons. Well, if here is my pentagon, right? So I would end up having 5 different congruent central angles right in here. So if that's the case, my degree of my central angle would be 360 divided by 5. In this case, I would end up having 6. So I would take 360 divided by 6. And of course, my next case, I would take 360 divided by 7. And then, of course, 360 divided by 8. So it's going to provide us, this formula will provide us, based on the number of central angles we end up having. So we get 360 divided by 5. Each of those would be 72 degrees. 360 divided by 6 is going to be 60 degrees. 360 divided by 7, we end up getting roughly 51.4 or so. 51, we'll put an approximation, 51.4 degrees. And then 360 divided by 8 is, of course, going to give us 45 degrees for those central angles. All right, so let's take a look here. Before we go into any of the areas yet, let's continue to look at some identification. I want to go ahead and just make sure that we're all on the same page in identifying actual parts of regular polygons once they're inscribed in a circle. So this particular square that we have is inscribed in circle K. Identify the center, the radius, and apothem and central angle, and then find the measure of the central angle. So the center, well, the center of that circle, of course, is going to be at point K, right there, the center of our circle. The radius can be KJ or KH. I think I said J, I'm sorry, KG, not KJ, KG. For our apothem, from the center, it has that vertex right there of our central angle to the side of the polygon, not to the circle, will be KL. The central angle would be GKH. And last but not least, a square is a regular polygon with 4 sides. So 4 sides is our value of n. So 360 divided by 4 will give us 90 degrees for the central angle of GKH. GKH would then be 90 degrees. So that's going to wrap up this video in just some basic identification. In our next video, we will look at actually utilizing it to find the area of these regular polygons.